Today I'm going to talk about what happens when recursive code is executed. What is going on in memory that makes it do some of the weird behaviors that you get when you run recursive code. So I've put a very simple function here, and then in a few minutes I'm going to do it with a more complicated one. But memory has this special area of memory just for storing function calls. Every function that's called is put upon this stack that keeps track of the state of that function. That way, if the function within it calls another function, it can jump away, do the inner function, and then keep track of where it was in this function so that when it comes back, it can keep going. So it's particularly important with recursion, but not just with recursion. Any function call uses this area of memory that we call the stack. So this particular example is a very simple one. If the num is 0, we return 0. Otherwise, we call the function again. We make a recursive call to the function, getting closer to the base case of 0 by saying the parameter's num minus 1 this time. And then we can add num to that. So all we're doing is really summing up the numbers up to the number. So this is just going to be 4 plus 3 plus 2 plus 1. But it doesn't do it with a loop. It does it by these inner function calls. So we talked about that before, and now I'm going to show you what's going on in memory. So let's see. I was going to put a text box here so you can see as soon as f of 4 is called down here, it's stored on the stack. F of 4, the call is letting, the stack keeps track of the fact that at this point num is 4. We're in the middle of the function, and we're at this point in the function, right here. So I'm going to kind of just put a dot here to remind us that that's the point where it's got to come back to. I guess I'll call this point A. Right here at this function call is where it's going to come back to after it comes back from doing this. That way it can still finish out the rest of the line and finish the function. So I'm going to put that it's in function F. Num is 4, and it's at point A. So what happens? It's at point A, and now it's got to get to f of num minus 1, so f of 3. So it's going to, again, make another text box here that I'm going to draw here. I'm trying to get used to Google Draw. This is f of 3 at point A. The same thing. So f of 3 starts over. It's not 0, so it gets to this line return, but it can't finish. It's got to start all over again, but it's got to keep track of the state. What we call the state of the function is we're in the middle of function where the where the num is 3, and we're at point A, and now we're going to start all over again, and this time with f of 2, because it says num minus 1. So another text box here. It's called a stack because everything stacks up like a stack of cafeteria trays or plates. You take the top one always, and when you put something on, you put it on the top. So that's why we call this a stack. Everything goes on the top. Nothing ever goes on the bottom. You continuously, anything you add to the top. And anything you take off of the top. So I'm going to do f of 2. And because I passed it num minus 1 this time, so I'm going to do f of 2 at point A. Now, here we are, f of 2 of point A. We've got to go to f of 1 of point A. One day we'll get through with this. At least it's only f of 4. Right here, we're in f of 1 at point A. Another recursive call has got to be made, and this time it's going to be f of 0 because num is 1 at this point, so num minus 1 is 0, f of 0. It still puts it on even though we can look ahead and see that it's almost done. We're in f of 0. F of 0, we don't ever get to point A, we just return 0. So immediately what's happened is called popping the stack. Popping the stack is just deleting the very top thing. So I can delete this text box completely. It's popping the stack, takes it off the stack. But where does it go after it's done with that 0? What does it do with that 0? It goes back to restore this state. That's called restoring the state of the function. So we go back to point A up f of 1. So we're right back here where we were before, but at this time num was 1. So we're able to get past point A now, finish this line, and say, what did we get back from that call? 0. We can add that to num, which in this particular instance of the function is 1. So we're going to return, we can finish this line, pop the stack again, and return something. And what do we return? 1, because that was 0. We are able to add 1. We're returning that 1, popping the stack, and giving that 1 back to the previous call. Where was it in the previous call, though? It was at point A. And what was num? 2. So we go back. It's point A in function at where num is 2. And we're able to add what we just got back, which was the 1, to num. What's num? 2. So now we have 3. We can pop the stack again. We have 3 that we can return back here. We're returning 3 to point A. Now we know this is 3. And what do we add? Num. Well, num at this time was 3, so we get 6. So return 6. Where do we return it? Back to f of 4. We pop all of those off the top of the stack. So we're back here, f of 4. We're at point A. We now know this is 6. We can add it to num, which is 4, so we get 10. So we can finally finish. We can finally pop the stack of that one. We're done with all of our calls here. We're back here, done with all our calls, and we have our answer, 10. Now I'm going to do a more complicated example. This one's got a lot of steps, and you have to be very careful because we're going to have a point A and a point B at which we're going to have to pause and save the state of the function because we have to do these 2 recursive calls instead of just 1. So let's look through this code. It's very simple, similar to the Fibonacci series, but not exactly. It's got its base case. If the number is anything less than or equal to 2, it returns 0. Otherwise, it has to start all over again, figure out what the result is of recurse 1 less, and add that to whatever the result is of recursing through 2 less, and then add 1 to that result. And that is how it's going to work. So it's very much more, you have to be very careful with what's going on the stack and what point you are. So this is just a recursive call. I just put point A and point B here to help us keep track of whether we were on this recursive call or this recursive call. So this one was simple. It only had 1 recursive call, but this one has got, I was going to try to make this easier for you to read, point A and point B. Each of these points, it stops because it makes a recursive call that we need the answer to. So we have to save the state, jump away, and start the function all over again with a different value for the parameter. So I'm going to try to be very slow and careful on what's going on the stack at each step of the way when I call recurse 6. So the very first call to this function called recurse creates an instance of the function here on the stack. And it says I want to call recurse. My num is 6. And 6 is not less than or equal to 2, so it's going to come down here, and it's going to save the state of the function. It's at point A. It's at point A, and now it makes another call to this function. So we have to keep track of where this call was made, but now we put another instance of the function here on top of it. Remember how stacks work. Each time something goes on top. So I'm going to call recurse 1 less. Num was 6, so now recurse 5. Right? I cannot keep going. I have to start all over. I can't go see what this one's going to be. I have to stop here and go try to solve this one. So I go say, what is recurse 5? Starts all over. Is 5 less than or equal to 2? No. So I have to get stuck again at point A. At point A, I have to now call recurse 4. Another instance is added to the stack, recurse 4. Again, it's not less than or equal to 2, so I got to get stuck again at point A and go make another instance, recurse 3. Recurse 3. I get to point A again. Now I got to call recurse 2. Recurse 2, however, is going to be easy for us. Recurse 2 is less than or equal to 2, so it's going to return 0. So yay, I can pop the stack, delete this text box here. I'm back down here. I'm able to get past point A. At point A, I have a result. It's 0. Can get past point A to solve recurse 3. So recurse 3 is going to be 0 plus whatever I get for recurse 1. Okay, recurse 1 needs to go up here. Recurse 1 is going to return 0. Recurse 1 goes away. And now we have 0 again. So we are able to solve recurse 3. We got a result for recurse 3. It is 0 plus 0 plus 1. So now we have a result here for recurse 3. We can pop the stack, pass that back down to the new one that's at the top of the stack. That was recurse 4. So we can pass it down, can get past point A in recurse 4 because now we have a solution for that. It's 1. So now, though, I've got to stop again at point B now. Now I'm at point B because I don't know the answer to recurse 2. Oh, yes I do, don't I? What was the result of recurse 2? Do I need to call it again? I guess I better to make sure everybody's got it. Recurse 2 up here on the stack. Oh, I'm sorry, recurse. Go back. Let's make sure everybody's got this. Don't want to get going too fast. I'm in the middle of point B of recurse 4. It gives me recurse 2, not recurse 3. Come up here. We know that answer, but I'm going to put it here anyway. I'm at recurse 2 because it's num minus 2 and num is 4. Recurse 2 is the one that returns 0. Pop the stack. I have an answer for that, so now I can get past point B by putting in the 0 for recurse 2, and then come here and add my 1, and I can finish recurse 4. Recurse 4 is done. The answer's 2. I'm done with that one, so I can pop the stack and go back to recurse 5, but at recurse 5 I was at point A. So recurse 5, I was at point A, and at point A, I got what I just had, which was 2. 2 gets sent back. I'm able to get past point A now of recurse this one and put a 2 there. And now I'm at point B. Point B of recurse 5 is calling recurse 3. Recurse 3 goes put on the stack. We can remember what recurse 3 was, but here's what happens. It gets put on the stack. It says what is, goes to point A. What's recurse 1? That was 0, so. What is recurse? 3 minus 1, 2. What was recurse 2? 0. What about this one? Recurse 1, 0. Oops, 0. And then over here, plus 1. So yay, we're done with recurse 3. It was 1. It was recurse 2 plus recurse. We're on this one. Recurse 2 plus recurse 1 plus 1. So recurse 3 was 1. Pop the stack. Send that back. That was at point B. It was 1. So recurse 5 is 2 plus 1 plus 1. 4. So that gets us past point A here. 4 is what was sent back for this when we're at recurse 6. Now we got to go to point B. Point B, recurse 4. Got to do it all again. What's recurse 4? Recurse 4. What is recurse 4? We're at point A again. Recurse 4. Oops, this was a -1. I don't know how I lost that. Recurse 4, point A, gives us recurse 3. I don't remember what that one was, so I've got to do this again. Let me put that I'm at point A here, so don't forget. Recurse 4, I'm at point A. I've got to come up here and do recurse 3. Recurse 3, this is what always happens. I get in a hurry, and that's what's going to happen to you too. So be super careful on these. Recurse 3 gives me at point A, recurse 1, we remember that's 0, plus recurse 2, we remember that's 0, plus 1. So I'm going to go on and skip a couple of steps here because y'all know what happens. It goes up to 2 and 1 and comes back with zeros. So that can pop back the stack. So we only got this 1 added. So now we can get past point A. I should have deleted all these boxes that aren't needed anymore. That one's not needed anymore either. I'm in the middle of this one. Point A gave me 1, right? Plus point B. What is giving me point B? Recurse 2, oh good, that's 0, plus the 1. So recurse 4 gives me 2. I can pop this stack here. I can go down here and say 4 plus 2 plus 1. So recurse 6 should give me 7 if I did all of mine right. So I'm going to run this and see if I was right, or I might have to do this video again. Invalid syntax, so that's because of all my point A and point B's. Get rid of those. Run this again. 7. The 10 was from the prior one. So all of those steps just to determine 7. Recursion is not very efficient. This one I can return 7 back, and that's what gets printed out. My stack is empty. I have 7 here. That was my result for recurse 6 through all of those steps. That's how you use the stack, and that's what's going on. It's not very efficient. It uses a lot of memory. It's very easy to run out of memory and get a stack overflow error.